It's 2026, and if you're not doing AI agents, you're really falling behind.
Using AI.
These AI agents.
AI.
Create AI agents.
In this video, we'll go into really simple, concrete basics of building an AI agent using Langchain and Python. Let's get to it. So here you see, I have a basic Python Jupyter notebook, and I've done some imports already. So if I execute this, you can see I'm using Langchain version 1.2. 1.2 is their latest stable version. So anything 1.x onwards, I recommend using that because that's stable. Langchain has been into a development beta mode for a while, but now they have done really good foundational work and they're a bit stable. So yeah, let's get to it. So before we start, we should really explain what an AI agent is actually. So if you look here, this is a super basic AI agent component diagram. It consists of an LLM, an input, which is given by us, an output, an LLM that can use tools to answer the question that we ask for. So this is a super basic AI agent. This is where our prompting happens. So we say, how's the weather today? And LLM goes and processes it and gives us the output. And the tools are actually the arms of the LLM. It's an ability for an LLM to fetch new data and get more context about the question, and then it processes it and gives the answer. Just imagine it's like a human brain. So now, given this concept, let's continue. So if you see here, you can import a create agent module from langchain.agents. And what it takes is a model parameter as input and a system prompt. So model here right now, I'm using a GPT-4o mini. This is from OpenAI. OpenAI has many models. Now 5.2 is there, but every model comes with a different cost. And since it's the demo purpose, I'm using the mini model. So system prompt is something that you want to guide the LLM that your agent should behave irrespective of the user input. So basically it's like a global prompt that your LLM will be aware of before executing any other user input. So let's say you can say you're a helpful assistant, or if you are building, like, let's say a coding agent, you can say you're an expert Python programmer, etc., etc. So that basically makes the LLM focused and it acts and does a role play. So here it's role playing itself as a helpful assistant. So let's execute this. And this, you see the agent is created. We can even print the agent, like what the agent is. So it says so it prints the flowchart of the agent, which is basically a start. Agent has a model in the end. So agent has no other components. We have not defined tools like we explained in the diagram, but it has very basic, which is basically this part here. So now we can invoke the agent, and invoking an agent has certain syntax from Langchain. So it has to be in a Python dictionary with the key messages, and then you can supply an array of messages. So our first message would be from a role user, and content of the messages. What is the weather in Tokyo, right? So I'm just asking an LLM, which does not have any connection to any tools, like what is the weather in Tokyo? So now if I execute this, it replies with a response. The response contains, again, an array of messages. One is the human message. That means whatever we sent as a query, which was what is the weather in Tokyo. And then an AI message, which is the response from the LLM, which says, I'm unable to provide real-time weather updates, blah, blah, blah. So basically the LLM is saying, because I'm not trained on the live data, I cannot provide a weather update in Tokyo because I don't have access to it. So this is a very basic AI agent. Now, to enable the LLM or the agent to access the real-time information, there are tools. So you can define a real API call as a tool. So let's see what the tool is. Tools can be specified as plain Python functions or coroutines. A tool decorator can be used to customize tool names, schemas, and other properties. So if we go here, what I've done is I've defined a function, which is a get weather, which takes a city as a string parameter and return, yeah, it's always sunny. So it's just like a mock API call to get the weather data, but you can actually write your real actual code here, your real API call here to actually like an open weather map or any other weather API that can get you the data for a city. So for the demo purposes, it's just a hard-coded string. And now we create a new agent, which is we're calling agent with tools, which says same model, same system prompt, but we're saying tools, which is a list. We say get weather. So basically this function is now a tool of this agent. So now if I print agent with tools, right, and execute this, now if you see, the agent is start, model, end like before, but it has a connection to a tool. Or here it says tools, but we have one tool, right? So now if we invoke it, the agent or the LLM should be able to utilize the tool and give you the answer. So if I now print the response and execute, and it's the same question, what is the weather in Tokyo? Now, if you see, we will be getting an AI message, the weather in Tokyo is sunny. So now it got aware that I have a tool that I can use to get the weather of a city, and it used it and it got the answer. So if you see in the response, it says it's a tool message. So from the tool, there is a message that LLM has read. So basically it's able to call the tool. So yeah, call the tool. So that's how now an LLM which is pre-trained to a certain date can have access to real-time data or any database or anything, and you can ask questions on it. So that's how you build tools around the agents. So now if you see, the sky's the limit. You can make the agent do anything and have any kind of tool defined here and then just query on it. So people are using it for databases, to query their PDFs, like 100 other things. The next part I want to cover is like structured outputs. So right now, if you see, the response from the LLM is a string, like the weather in Tokyo is sunny is a string. So there is no format like a JSON, no structure to it. Like it can produce a random natural language string with the answer, because right now our tool is pretty small. But let's say if our tool was something complicated or multiple tools, it can just give a big response, you know, like how ChatGPT does, like big responses. So if you use structured outputs, you can let the LLM respond in a certain format, which you can then use for input to other functions or do anything else with. So that makes our whole system very composable. Like we can tool an LLM response as a function, like because it has a certain return type. So structured outputs are a way to specify format of the response from the model. Okay. So I think one of the best ways to do it is using Pydantic, because Pydantic lets you specify the types and the fields, and also it does the validation for you. You import a base model and a field from Pydantic. So now I've said, okay, in order to give me the format of weather, I have a class weather, which has city and a weather parameter, city of type string, which is like city to get weather for, and the weather is the actual weather of the city. So now we'll create a new agent, same model, same tool, same system prompt, but we say response format is of type weather, which is this class. So now when we call this, the agent should be able to respond in this structure. So let's run this and check. So now when I execute this, oh, I forgot to print the response. So let's print the response. So now you see, so now the AI message has turned into a JSON, which is like city, Tokyo, and weather, it's always sunny. So we have a certain format for it. So now what you can do is you can do a model dump JSON, which is a Pydantic feature where it can convert the model, which is this, which is the Pydantic base model type, into a JSON type. So now you can use it in any other composability use cases. So now the next part I want to talk about is streaming. So now in streaming, what happens is you can import the actual model from the Langchain integrations like Chat OpenAI, which connects to an OpenAI model, and then initialize the model as streaming true, which means now you're saying, okay, I'm initiating a mod instance, but with a streaming capability. And now what this does is you can do a model.stream instead of invoke. So let's just print this first. So I'm copying this, I'm pasting this. Let's comment these two lines out and then see what this responds with. So basically it responds to the Python generator. Then you can iterate on to get chunks out of the stream. So let's uncomment this and comment it back. So here what I'm doing is for each chunk in model.stream in the same message, print the chunk.content. And this is a delimiter, like I can just put this delimiter as well, and then flush equal to true, so that it does not buffer the response. It just prints at every chunk. So this is just a Python thing that you can do at and make flush equal to true. And now if I run this, is you see each token as it gets generated, you can just see, you don't have to wait for it. So guys, this gives you all the building blocks to build any simple agent, where basically you can connect to a model, add a tool to it, and then add streaming capabilities to it. So now it just puts together the whole complete picture for the agent. There are some advanced concepts that we can learn in the future videos, which is memory, middlewares, and other things, which will help you build agents in a more robust manner. But this is a really good starting point, and I believe you can really start building your own agents now. And I hope you like this video, and please comment if you find this useful or if you want to learn something specific. I'll be happy to keep sharing my journey with you guys, because I'm also learning this stuff and would love to pair program and do it together. Cheers.